Hello people, welcome back to my channel. So today in this video, let's talk regarding the ensemble methods. Now ensemble methods are also called as classifier combination methods, means it has different base classifiers or base learners, and the predictions of each of those base classifiers are combined with the help of majority vote, and then it is given to the test sample. So let's begin with the basic definition of what ensemble methods are. So ensemble methods are meta algorithms which combine multiple machine learning techniques into one predictive model to achieve one of these, that is to decrease the variance, and so we have the process called as bagging. Then to decrease the bias we have boosting, and then to improve the predictions we have something called as stacking process. So in order to give an idea, we have the training data. So training data is being divided into multiple data sets. Say you have dn, and it is given to each of the classifier, and so they produce different predictions, and all these predictions are combined into one learner or one classifier. So this gives the better output than any of these single classifiers. Now ensemble methods are mainly divided into two categories. You have sequential ensemble methods as well as parallel ensemble methods. Now in sequential ensemble methods, the base classifiers which are there, those are created sequentially, and in parallel they are created parallelly. So this is the overview of how the ensemble methods are. Now one main question is why we need to use ensemble methods. Like we have the other classifiers, we have SVM, decision trees, naive Bayes or nearest neighbors. So why we require an ensemble of all these base classifiers in order to give the prediction? So let me explain that with the help of an example. Say for instance you have 25 base classifiers. Now these are binary classifiers. Binary classifier means the output or the prediction could be 1 or 0, or it can be true or false, yes or no, or it can be plus or minus. So any of these are called as a binary classifier. Now what I've said is, in ensemble methods you take all these binary classifiers or base classifiers and then you give the prediction as the output. So say for instance if this binary classifiers are identical, or it means like if I say I've taken decision trees, all decision trees that I've taken as a base classifier, means the prediction given by same base classifier, and before that let the error estimate be something 0.35. Now you have 25 base classifiers, so a total of 25 into 0.35, it will produce a error of 8.75. Now if the base classifiers are same, then the error that it's being wrongly predicted would be equal to 0.35, which is what each of the base classifier has got. Now if your base classifiers are different, means the errors are uncorrelated, means in the initial case this was decision tree, this was decision tree, and this was decision tree. Now in this case this could be decision tree, or this could be naive Bayes, this could be SVM, and there could be nearest neighbors, logistic regression, linear regression. So in similar way, if you have different base classifiers and the errors are not correlated, means they are not dependent on the above base classifier, so in this case the prediction of your ensemble will be dependent on more than half. So if your base classifiers which are more than half of 25, then it will wrongly predict. means the prediction comes to be wrong. So this estimate is mathematically given by, so you have estimate for or error estimate for ensemble. So it is given by summation I runs from 1 to 13 to 25. You have 25i epsilon raised to I and 1 minus epsilon raised to 25 minus I. So why I runs from 13 to 25? Why? Because if it's more than half, means the base classifier predictions are wrongly classified for more than half, means half of 25 is 12.5, so I've taken 13. So if this runs from this till here, so it means that the errors are uncorrelated, and so if you solve for this value, you get an error estimate of 0.06. Now you just compare this error with 0.35, so which is smaller, that is error of ensemble. So that's why we go with the ensemble method. So this was an example. Now let us consider the way of how to generate the ensemble classifier. So there exist 5 different ways in which can generate the ensemble classifiers. So the very first method is that we can manipulate the training data. So with the training data instances, you can manipulate all the data sampling techniques, and so you have bagging technique and boosting. So with that you can generate the ensemble classifier. Second way is to manipulate the input features. So in this you select a subset of the features, not all the features which are required for your model generation. So an example could be random forest. Third way is by manipulating the class labels. So in this what you create is, you create an artificial label, say A0, A1, and A0 will corresponds to 0 class label or A1 corresponds to 1 class label. So this is mainly used in technique called as ECOC, that is error correcting output coding. So this we'll see in detail in multi-class classification problem. And fourth method is that we have manipulating the learning algorithm. So manipulating the learning algorithm, like for example you have artificial neural networks, so you have different models or topologies. So with the help of this you have a hidden layer, and so you generate one model or output or prediction. So with this what you can do is you can change the weights, or you can change the neuron connections, or the topology in fact you can change, and you can generate a new model. So by this all techniques, that is 4 techniques, you can generate the ensemble classifier. Now this is what you can see. This diagram is the logical view of ensemble classifier. So this is how it looks basically. So you originally have the training data which I have spoken here, that is represented by D. Then you create multiple data sets by it. So you have, for T instances you have T data sets created, and for each of this data set you create multiple classifiers. So it can be same classifier or different. So our requirement is mainly to have a independent classifier, means they should be uncorrelated. So that is the main scenario of this. So you need to consider different base classifiers. So this can be decision tree, this can be naive Bayes, or this can be SVM, or this can be some logistic regression. So anything like this, and finally you combine all these classifiers to give the prediction as output. So a majority voting scheme is employed in this technique to classify a new test instance or to classify its new class. Now there is one more thing, is that this ensemble methods work well with unstable classifiers. Now what is unstable classifiers? So unstable classifiers, basically I can give examples of decision tree, or you can have rule based classifiers, or say for example artificial neural networks. So all these are unstable classifiers. Now why it's called as unstable, or what there is instability? So basically if you see the training data of these models, even if the minor perturbations in the training data can cause a drastic change in the prediction of that particular data set or value. So that's why it's called as an unstable classifier. So well, that was all regarding the ensemble methods in machine learning. So hope you guys enjoyed this video. If you found you got educated by watching this video, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.